The next type or pattern of example again related to the work done what we have discussed. Show that f bar is equal to 2xy plus z cube into I plus x square j plus 3x z square k is a conservative force field. Find the scalar potential. Also find the work done in moving an object in this field from point 1 minus 2 1 to 3 1 4. Now, in the case wherein we are calculating the work done moving from point A to point B, initially we will be calculating del cross f bar. Del cross f bar is determinant ijk, del by del x, del by del y, del by del z, and del cross f is equal to, after simplification, we are able to show that it is conservative. So f bar is equal to grad phi, equate it with I times del phi by del x, j times del phi by del y, plus k times del phi by del z. You get del phi by del x, del phi by del y, del phi by del z. Integrate equation 1, 2 and 3 respectively with x, y and z. Get the cumulative phi. So phi is now expressed as x square y plus z cube into x. So work done in moving from point A to point B. So point phi at point B minus phi at point A, and that answer comes out to be 202. All the quantities are real number, so therefore there will be the answer which is in the form of real number. So this was one of the similar kind of problem wherein we have dealt it with the work done. Yes, this is one of the different example. Find the constants a and b so that the surfaces 5x square minus 2yz minus 9x equal to 0 and ax square y plus bz cube is equal to 4 may cut orthogonally at a point 1 minus 1 2. Now, what do we understand by cut orthogonally? Angle between them is 90 degree. Now, how you determine the angle? Angle is taken with the help of the dot product. That too for the surfaces. The vector normal is nothing but your grad phi, whatever we have done prior to this. So let first surface be phi 1, second surface be phi 2. N1 bar will nothing but be the normal to the surface phi 1, which is grad phi 1. Grad phi 1 means del phi 1 by del x into I, del phi 1 by del y into j, del phi 1 by del z into k. So appropriately you are getting down the derivative, and at point 1 minus 1 2 we get the vector as I minus 4j plus 2k. Second vector n2, which is normal to the surface phi 2, that is del phi 2 grad phi 2. Appropriately find out the differentiation and put it or obtain the value at point 1 minus 1 2. So this is what we are going to get the value for the second vector. Now it cuts orthogonally means angle is 90 degree. Angle is 90 degree, and with the help of the dot product I know that a bar dot b bar is ab cos theta and cos 90 is 0. So a bar dot b bar comes out to be 0. So whenever I say that it cuts orthogonally, dot product between the two surfaces for the gradient what we have calculated will be 0. So since the given surfaces are orthogonal at 1 minus 1 2, we have n1 dot n2 is equal to 0. So take the dot product of this with this, equate it with 0, you get the answer as a is equal to 4b. Now also one of the surfaces which contains a shall help us to get the value. So as the surfaces meet each other at point 1 minus 1 2, the connection or the relation what we get is a plus minus a plus 8b is equal to 4. So one of the relation what I am getting after using the orthogonality concept is a is equal to 4b. Now put the point 1 minus 1 2 here. So x is equal to 1, y is equal to minus 1. So it becomes minus a plus b into z cube means 8b is equal to 4. Also this particular point satisfies the given curve. So the second equation what will be generated is minus a plus a to b is equal to 4. One of the value what I have got is a is equal to 4b. After simplifying, I am getting the answer as b is equal to 1 and a is equal to 4. So therefore we are getting down the answer as a is equal to 4 and b is equal to 1. So whenever the word orthogonal is used, it indirectly divert us to the concept that angle is 90 degree, and whenever we are connected or associated with the angle, we consider the dot product. A bar dot b bar is equal to ab cos theta. Cos 90 degree is 0, therefore a bar dot b bar is equal to 0. But here initially the surfaces were provided, so gradient is nothing but that vector quantity whose dot product can be taken in the form of vector normal to the surface. So I denote n1 as normal to the surface phi1, I denote n2 as normal to the surface phi2, and we get the answer. Similarly, another question wherein the word orthogonal is involved. A bar is equal to this vector. Find curl A bar and show that the vectors given by curl A bar at point this and this are orthogonal. See, curl A bar is a vector quantity. One of the point is given by 1, 2, minus 3. You calculate curl at this point. You calculate curl at this point. Take the dot product. If that answer comes out to be 0 for the given requisite vectors, we say that they are orthogonal. So A bar is given by this. Calculate curl A bar. Curl A bar निकाल लिया. Differentiation करके ये आंसर आ गया. Curl at point 1, 2, minus 3 is minus 3i minus k. Curl at point 2, 3, 12 is minus 5y plus 15k. A1 dot A2 सॉल्व करके अगर आंसर 0 आता है, I say that curl A bar at point this is orthogonal to curl at point this, and hence dot product is equal to 0, means angle is 90 degree, and the surfaces or the vectors are orthogonal to each other. So this is one of the kind of example wherein you are exposed to the word orthogonal and about the orthogonality of the given vectors. The last question wherein it is just the analytical portion without any data provided, show that curl of grad phi is equal to 0. Now curl of grad phi, जिस किसी का भी कर्ल लेना है मींस उसके साथ वो क्रॉस प्रोडक्ट डेल का लिया जाएगा, बट ग्रेड फाई इटसेल्फ इज del phi by del xi, del phi by del yj, del phi by del zk, which is gradient of phi. So curl grad phi means del cross grad phi, means determinant I j k del का कंपोनेंट होता है del by del x, del by del y, del by del z, that will be the second row. Third row will contain the component of grad phi. Those are del phi by del x, del phi by del y, del phi by del z. Cross multiply, take the derivative. Del by del y of this is del 2 phi by del y del z. Del by del z of this is del 2 phi by del y del z. दोनों quantity same है तो क्या आएगा आंसर 0. Similarly, these two derivatives will also be same 0. So 0i plus 0j plus 0k is 0. So curl of grad phi is 0. Second is divergence of curl A bar is equal to 0. Divergence means del dot, whatever will be the vector quantity in the curl A bar, that will be shown 0. A bar is any given vector expressed in a component form as a1i plus a2j plus a3k. F bar will nothing but be the curl of A bar del cross A bar. del cross A bar इस तरीके से दिया गया है, del A3 by del y, del A2 by del z. सिंप्लीफाई कैंसल नहीं होगा. F bar is nothing but F1i plus F2j plus F3k. So ये आपका हो गया F1, ये हो गया F2, ये हो गया F3. Now del dot F bar यानी क्या होगा, derivative of this quantity. Why I have represented it by F1, F2, F3? Because I have to take the divergence. Divergence is nothing but dot product. Dot product is always scalar. So instead of keeping it in the bracket, which will increase the complication, what I do is I represent this f bar as f1i, f2j, f3k, where what is f1? F1 is this bracket, f2 is this bracket, f3 is this bracket. Now del dot f bar will nothing but be divergence of this curl a bar, right? So del dot f bar means del f1 by del x, del f2 by del y, del f3 by del z. This particular quantity contains the derivative with respect to y and z. When it will be differentiated with respect to x, y and z will be treated constant. So ultimately those becomes all get cancelled out and your answer remains the value as 0. See, del 2 a3 by del x del y, del 2 a2 by del x del z, del 2 a1 by del y del z, all are getting cancelled and finally your answer comes out to be 0. So in this manner, we are able to show divergence of curl a bar is equal to 0. So this particular example